and we will start the session now. Are you ready? जल्दी से टाइप करो कमेंट बॉक्स में ready हो या नहीं हो. Let's quickly recap what exactly we have studied till now. So we have studied the basics of data structure. After that we have studied array, entire data structure, array, searching, finding minimum, maximum, insertion, traversing, and after that second minimum and minimum maximum, both with minimum comparison, 2D array and multiple types of 2D array, sparse matrix like lower triangular, upper triangular, and so on. So many things we have seen in the array. After that we have gone for linked list. In the linked list we have seen the access of the linked list, then we have seen insertion, traversing, finding the address of the last node, counting the number of nodes, and multiple other things we have seen. Today we are going to check out if we are going to delete. If you are going to delete in the linked list, what happens? Okay, so let me make it as deletion, not insertion. If you want to delete in the linked list, what happens? So you can delete the nodes from different places. You can delete the node from different places based on the requirement. जो node को delete करने को बोला है उसे हम delete कर देंगे. चलिए तो देखते हैं सबसे पहला डिलीशन. बहुत आसान सा होता है डिलीशन. डिलीशन मींस रिमूविंग एन एलिमेंट फ्रॉम द लिंक लिस्ट. So if the deletion says deletion of the very first node, what should I do in this? क्या करेंगे? पहली नोड डिलीट कर दें, ये खत्म हो गया मामला? No, this is not yet done. This is not the way to delete the node. I'll have to change some pointers. कुछ pointers change करने पड़ेंगे so that after removing this particular first node, I can say that okay, first node got eliminated and remaining linked list is starting from my list pointer. What should I do? 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 Now, exactly if I remove this particular first node, then the second node becomes my first node. If second node becomes my first node, then my list pointer should point to my second node. So what updation I'll have to do for deletion? I'll have to update my start pointer. I'll have to update my start pointer. I'll have to update my start pointer by the address of second node. How do I do that? कैसे करेंगे? I will update start pointer by address of the second node. Address of the second node I will get from the link part of the first node. I'll do it like that way. Now, if you will remove this particular node, abhi this particular node's allocation has not gone from the memory. अभी भी ये space allocated है, linked list से हट गया but allocated तो है. You have removed this node from the linked list but still it is there in the memory. If I am deleting a node, it's always good to free the space allocated to this node. It will always be good. So what we will do first, before deleting the node, what I will do, I will take a pointer, let's say P. In that pointer P, I will first take the address of that first node. And after that, removing that first node from my linked list by updating start by address of the second node. After that, I will make the allocation done for this particular node free. इससे होगा क्या? इससे ये होगा कि मेमोरी में फालतू की जगह ऑक्यूपाइड नहीं होगी. Unnecessary space will not be available in my memory allocated. I will free means I will deallocate the memory which was allocated to this node. It's a good practice to write. Hence, I am writing. Okay, Vamsi says that I failed in GATE 21. Shall I try for GATE 22? Vamsi, it's very simple thing that what satisfies you in your life. If you feel like you have courage, if you have that potential to crack the GATE with the highest rank, then go for 22 exam also. But I would like to give you suggestion, and the suggestion is if you are really interested to go for GATE preparation, then please don't take risk with your preparation plan. Make a good plan, study under guidance of an expert who can give you good suggestions so that you don't waste your time, you don't waste your efforts, and you study with the top educators of country so that you can understand each and every topic with the highest level of learning. If possible, you can join Unacademy Plus, that would be best. But if not, then at least go for these suggestions. चलिए आगे बढ़ते हैं. ये पहला डिलीशन समझ में आया सबको? अगर पहला डिलीशन समझ में आ गया है तो हम आगे बढ़ेंगे. जितने लोग अभी यहाँ पे हैं, अगर सेशन लाइक नहीं किया, एंजॉय कर रहे हो तो सेशन लाइक कर दो यार, और साथ ही साथ जल्दी से बता दो डिड यू अंडरस्टैंड दिस. इफ यस देन लेट्स गो फॉर दिस वन, डिलीशन ऑफ द लास्ट नोड. Let's delete the last node. If I will have to delete the last node, what I will have to do? क्या changes मुझे करने पड़ेंगे इस particular linked list में? Can you tell me what should I do? What changes I'll have to do to delete the last node? If I delete this particular last node, this becomes second last node becomes the last. In that case, second last nodes next should be null. Right? Okay, fine. So how can I do this? 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 I'll have to find out the address of this particular node, and its link part I'll have to update by null. But do I know the address of second last node? No. I can get it directly from the given start pointer? No. Then what should I do? क्या करेंगे? डायरेक्ट भी नहीं मिल सकता, दिया हुआ भी नहीं है, तो फाइंड करना पड़ेगा. कैसे? हाउ कैन आई फाइंड द सेकेंड लास्ट नोड्स एड्रेस? How can I find the second last node's address? I'll have to traverse from starting. I will have to traverse the list from starting. So I'll write down the algorithm. I'll be taking a pointer P that will start from start, and I will have to stop pointer P on the second last node. Means I will run the loop while जब तक तब तक की सेकेंड लास्ट नोड पे नहीं पहुंच जाए. मींस P का लिंक जब तक ट्रू है तब तक P को आगे बढ़ाते रहो. कीप इंक्रीमेंटिंग P by its next. When P reaches here, second last node, after that I'll have to do what? P का link I'll have to update by null, so that I can delete this particular node. Now I will have to handle the conditions. What are the conditions? The base conditions. If you don't have any node, then अगर आपके पास नोड ही नहीं है, empty list है, तो क्या करेंगे? And if you have only single node, second last तो कुछ होगा ही नहीं, then क्या करेंगे? So in that case I am writing the base case here. The base case should be if the start pointer is null. If start is equal to null, means it's an underflow का केस. किसका केस है? अंडरफ्लो का. तो हम यहां पे लिखेंगे अंडरफ्लो एंड रिटर्न. प्रिंट कर दो अंडरफ्लो और वापस चले जाओ. आपका काम नहीं हो सकता. Let's say second statement is if start का link is equal to null. Means you do have only one node. If you do have equal to null. If you have only single node, what should I do? That single node will be deleted. That single node will be deleted after that. Okay, I'll give you the scenario. Single node means start is pointing to a node and that particular node is the single node. Its next is null. Start का link is equal to null. Single node is there. Yes, after deletion of this, ये start के पास क्या मिलेगा? ठन ठन गोपाल कुछ भी नहीं. right? What happens in that case? So start ka link is equal to null. If single node you have, in that particular case you will have to write here, you update start by null. Start equals to null and return. So once list becomes empty, you return. If not, if you don't have 0 node, 1 node, more than 1 node you have, then you can go with this. You can go with this particular case. अब देखिए कॉम्प्लेक्सिटी एनालिसिस करते हैं दोनों की. ये भी कॉम्प्लेक्सिटी एनालिसिस नहीं किया मैंने. इसका कॉम्प्लेक्सिटी क्या होगा? अल्टीमेटली फॉर डिलीशन यू आर राइटिंग ओनली सिंगल स्टेटमेंट, ओनली कांस्टेंट नंबर ऑफ स्टेटमेंट्स. सो इन दिस पर्टिकुलर केस whether you have 1 element, 2 element, 3, 4, 5, 6, 100, 200, 500 elements, deletion of the first node will take constant. क्यों? क्योंकि only one statement you are executing. You are not running any loop. You are not executing the number of statements which are directly dependent on the number of nodes. Number of nodes से कोई लेना देना नहीं. एक हो या हजार हो, एक स्टेटमेंट से काम चल जाएगा, बिल्कुल चल जाएगा. तो यहां आंसर क्या आएगा? रन टाइम कॉम्प्लेक्सिटी. आई एम राइटिंग कॉम्प्लेक्सिटी मीन्स रन टाइम कॉम्प्लेक्सिटी ओनली, एंड दैट विल बी इक्वल टू कांस्टेंट. Constant is big O of 1 or theta of 1, you can write down. But here what should I write as the complexity? What should be the complexity in this case? In this case we require loop. Yes, we require traversing from first to last. Yes. So runtime complexity here will be theta of n, क्योंकि complexity में हमारे पास यहाँ पे आएगा traversing. अरे शाबाश 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 शाबाश, great great. Now listen. I'm telling you one thing. So many students ask me, sir, एक बहुत अच्छा सा मैसेज भी आया है, कमेंट भी आया है कि सर क्या हमें सी लैंग्वेज को छोड़ के दूसरे लैंग्वेजेस में भी डेटा स्ट्रक्चर सीखने की जरूरत है? देखिए डियर, आई एम टीचिंग यू हियर फॉर गेट एग्जाम प्रिपरेशन, एंड गेट एग्जाम में आपके पास प्रोग्रामिंग लैंग्वेज स्पेसिफिकली सी लैंग्वेज ही है और डेटा स्ट्रक्चर भी विद सी लैंग्वेज है. तो दे डोंट आस्क क्वेश्चंस बेस्ड ऑन एनी अदर लैंग्वेज इन द डेटा स्ट्रक्चर आल्सो. दैट इज व्हाई वी आर स्टडीइंग ऑल दिस. इसीलिए हम ये सिर्फ सी लैंग्वेज में पढ़ते हैं. आपको इंडस्ट्री ओरिएंटेड स्टडी करना है, यू कैन गो फॉर पाइथन, जावा, समथिंग एल्स. डेटा स्ट्रक्चर विद पाइथन, डेटा स्ट्रक्चर विद जावा, you can go with those. But because we have GATE syllabus confined to only C language, we are studying everything in the C language, in fact in data structure also. अब बात करते हैं deletion of a given node. So this particular word has really great meaning. The node is already given. Node is already given means here some node's address will be always given in the algorithm. Let's say I have given you address of this particular node as address in LOC. So LOC is the pointer pointing to that node which I'll have to delete. एक ऐसी node जिसे delete करना है जिसका address already mentioned है. I don't have to find it. I already have it. So in the algorithm, if you write algorithm will have deletion, algorithm will have input as a start pointer of course and an LOC pointer to delete that particular node. Now you will have to write the algorithm. ये सारी एल्गोरिदम पता है मैं क्यों लिख रहा हूं? Just because two reasons are there. ये एल्गोरिदम you will not get directly as it is in the exam कि इसका एल्गोरिदम लिखो. They will not ask you to write the algorithm. No, not at all. But there are two reasons I am giving you the algorithms of these each and every single scenario, so that you can understand how the operation is performed, so that you can understand exactly how these deletions can be performed. And the second reason is they may give you a large algorithm and they may ask you that one statement is missing. Which statement is that? So if you understand these algorithms and if you understand the idea behind these statements of algorithms, you will be able to write the correct statement in the GATE exam easily. Now let's try to delete the given node. I'll have to delete this particular node. If I'll have to delete this node, what I'll have to change is predecessor of LOC. I'll have to update by, or link part of previous node of LOC, I'll have to update by LOC ka next. Yeah, I can get the address of this node from LOC's link. Yes. Can I get the address of predecessor of LOC? No. 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 So if I don't have the address of predecessor of LOC, then in that particular case, I will have to find it. I'll have to find it. How? Traversing. Simple. So let's traverse and first of all find the address of predecessor of LOC. Let's do that. So I will take a pointer P from starting and I will start P where? Here. Means P ka link becomes LOC. So I will write down while P ka link not equal to LOC, till that time increase P equals to P ka link. Right, once P reaches here, after that what I can do is I can update what P ka link, which is currently equal to LOC. This one I'll have to update by LOC ka link. So LOC node is deleted. But here also I'll have to handle one boundary condition. What is the boundary condition? अगर LOC पहली ही node का address given होता तो, if LOC is the first node's address only, then in that case, can I find predecessor of LOC? There is no any predecessor of LOC at all. So what I will do is I will handle the boundary condition here. If LOC is equal to start, मुझे पहली ही node delete करनी है, उस केस में I will write down start is equal to start का link. Delete the first node by updating start pointer by start ka link, and then I will return. Now, what is the complexity? What is the complexity? What is the complexity? Run time complexity is equal to what? Big O of n. अब ऐसा क्यों लिखा सर? Big O of n क्यों लिखा? Theta of n क्यों नहीं लिखा? Depends on where the location LOC node given. Where actually LOC given. LOC is given first node's address. This particular first statement is required. Remaining algorithm will not run. If it is second node's address, this loop will run only one time, first time condition check. If LOC is given at the last node, I'll have to run the loop for almost all the nodes. Means if LOC is given at first or second or third node or fourth node or the last node, depends on which I will be running my algorithm's statements. So maximum n times I will run the loop, and maximum n statements I will be running, n operations I will be performing for finding predecessor, and after that constant operation this. That's it. That's it. But LOC, if it is at the last node, then maximum n. It might possible that minimum can be constant operation. This one. If I'll have to delete the first node. That is why big O of n. Big O of n. चलिए, एक बहुत अच्छा क्वेश्चन आया है कि सर गेट मैथ्स के लिए कैसे पढ़ें. तो एक काम कीजिए, आप अनअकैडमी प्लेटफॉर्म पे जाइए. अनअकैडमी प्लेटफॉर्म पे जाके एक टीचर हैं जिनका मैं आपको रेफरेंस देता हूं, उनका नाम है उमा महेश्वर. ठीक है, उमा महेश्वर नाम है, उन टीचर से आप मिलिए, उनसे बात कीजिए. जस्ट सेंड हिम मैसेजेस ऑन अनअकैडमीज लर्नर ऐप. Once you will talk to him, he will be able to give the appropriate answer that how to prepare for GATE mathematics specifically. GATE mathematics. ठीक है, ठीक है, ठीक है. चलिए वापस आते हैं. तो कॉम्प्लेक्सिटी बिग ऑफ एन इसलिए है क्योंकि हमें नहीं पता कि एलओसी कौन सी वाली नोड है, पहली है कि दूसरी है कि तीसरी है कि चौथी है, लास्ट भी हो सकती है. अगर एलओसी में लास्ट नोड का एड्रेस दे रखा है तो ये वाला जो लूप है वो चलेगा n टाइम्स, उसकी वजह से कॉम्प्लेक्सिटी n हो जाएगी. बट अगर एलओसी फर्स्ट नोड का एड्रेस दे रखा है तो ये लूप सिर्फ एक ही बार चलेगा, एक भी बार ना चले हो सकता है. तो मैक्सिमम n टाइम्स लूप चलेगा, यस, मिनिमम एक बार भी ना चले. दैट्स वाई बिग ऑफ एन. मैक्सिमम एन, उससे कम में भी काम हो सकता है. दैट इज वाई बिग ऑफ एन इज द कॉम्प्लेक्सिटी फॉर डिलीशन ऑफ अ गिवन नोड. चलिए आगे बढ़ते. डिलीशन आफ्टर अ गिवन नोड मतलब कि अब आपको एक नोड डिलीट करना है गिवन नोड के बाद की. यू विल हैव टू डिलीट अ नोड विच इज the next node after a given node. Suppose LOC is this one, LOC given, this node's address is given, so next of that I'll have to delete this one. If I'll have to delete this particular node, how can I do that? What changes? See, the very first thing is visualize what kind of changes you will have to make to delete this particular node. If I'll delete this particular node, what should be the next of LOC? Link part of LOC should not point this just because it is got deleted now. It has got deleted now, so LOC ka link should be this node's address. In this particular case, what should I write is I'll have to just update one link, LOC ka link, which is updated by this node's address. How can I reach here? LOC ka next, LOC का लिंक के लिंक से. That's it. Yes, that's it. And deletion done. Yes, deletion done. So, what should be the complexity of this? Complexity क्या हो जाएगी? The complexity of this algorithm is constant. Pam 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 para. Ta-da, ta-da. Got it? I guess you understood. मुझे ऐसा फील हो रहा है कि आप समझ पा रहे हैं चीजों को. So let's go for another concept. See, what I told till now is deletion is done how we are updating the pointers. I have told you that you will have to free the nodes also which you are deleting. Of course, if in this particular case, suppose this last node you are deleting, you will have to take the address of this last node in some pointer before removing this from the linked list, and after that at the end you will have to make it free. You will have to do it when you will be writing actual programs. Right now I'm not telling you, giving you just because for updation of links and all it is not necessary, but for the valid work of your memory management you should do it. Here also yes, here also yes, you will have to take this node's address in some pointer, and after that you will have to remove it so that you can say हाँ भाई इसका allocation deallocate हो गया है. But here in this particular case there is a catch, there is a boundary condition. If LOC is given as the last node, then what we will do? Can you do this? If LOC is given as the address of the last node, then can you delete the next node of the LOC? No, you can't. So if no, then you will have to handle a boundary condition like this. If LOC का link is equal to null. If LOC का link is equal to null means you are trying to delete no any node. LOC का next कुछ नहीं. After LOC nothing means return. Nothing is there. You can't delete any node, return. So if LOC का link is null means LOC is pointing to the last node. After that there is no any node. You can't delete. If you can't delete then return. नहीं करना कुछ भी हमको. हम delete ही नहीं कर सकते तो हम कुछ नहीं कर रहे. Fine. So I'll have to write this if LOC का link is equal to null, return, otherwise go for it. चलिए आगे बढ़ते हैं. Let's go for the next one. Deletion before a given node. Now I have given you address of a node already in the pointer LOC. You'll have to delete the predecessor of it. Can you do it? Yes. But how will you do it? First of all, you will have to understand if you want to delete this particular node, what pointers you will have to change, what links you will have to change. LOC के predecessor. Here in this particular node, link part now should update or should be updated by LOC. This I'll have to do. But the problem is, do I know the address of this second predecessor of LOC? No. Can I do or can I directly get it from LOC? No. I'll have to traverse from starting. I'll have to traverse from starting and I'll have to stop my pointer P when P reaches to second predecessor of LOC, previous to the previous of LOC. Right. So let me first write this. After that I will come to the base conditions. पहले ये लिख लेते हैं, उसके बाद base condition पे आएंगे. So let me write down this way. If let's start with the P is equal to starting from start, and after that I will write a loop while P का link and उसका link is equal to LOC. P's link and its link not become equal to LOC. Till that time repeat and continue updating by P ka link, the P pointer. Once P reaches here, what should I change? क्या बदलाव करना पड़ेगा, क्या तब्दीली करनी पड़ेगी? Link part of P I'll have to update. Link part of P I will have to update by what? LOC. I can directly write here LOC, this node's address. Yes, I did it. But what is the base condition here? यहाँ पे base condition क्या होगी? यहाँ पे base condition क्या होगी? Base condition क्या होगी यहाँ पे? यहाँ पे base condition होगी if LOC is the first node, then previous to this is nothing. Previous to this is nothing. No. So if base condition I want to write, I will write if LOC is equal to start. In that particular case, I cannot delete the node before LOC. I'll have to just return. Can't delete it. One more base case is there. Which is that अगर LOC second node है, if LOC is the second node, in that particular case I'll have to delete the first node. In that case I'll have to change the start pointer, just because I do not have second predecessor of LOC here. LOC का previous I don't have. Because of that I'll have to include this also in my base case. So the base case, another base case is if start ka link is equal to LOC, means the LOC is the second node. I'll have to delete the first node. In that case I'll have to update start by LOC. I'll have to delete first node, start will be updated by LOC, which is nothing but start ka link, and then return. I'll have to return back from this algorithm. Done. I cannot do remaining things. Yes, every time when we are deleting, you will have to make the node free also. I am not talking about that particular point, just because that is not very necessary for GATE preparation. इसलिए मैं उसकी बात नहीं कर रहा हूं। जो भी नोड आप डिलीट करोगे उसे आपको फ्री करना पड़ेगा। यस, यू विल हैव टू डू इट। चलो आगे बढ़ते हैं। नेक्स्ट इज application of linked list. So these are the different types of deletion we have seen. One thing we have not seen is the complexity of this. One thing we have not seen is the complexity of this. What is the complexity? What is the runtime complexity of this particular algorithm? See, in this particular algorithm also we have a traversing, but that particular traversing will not always reach to the last node. That traversing will reach to the LOC only. So depends on the position of LOC, this loop runs. Hence the complexity will be big of n. It can be maximum n times you will run the loop. It can be even lesser than n times you will run the loop. Depends on where the LOC is given, where the location of the node is given. If it is first, second, third or near to the starting, you will be getting that particular loop running less than n times. Okay, got it. चलिए एक छोटा सा अपडेट देना चाहूंगा. Tomorrow morning we are having a session. That particular session is meant for those members who are preparing for GATE also and for competitive coding or maybe placement also. All those members जिनको प्लेसमेंट एंड गेट की दोनों की तैयारी करनी है, उनके लिए एक सेशन है, बड़ा सा इंटरेस्टिंग सा सेशन है. द सेशन इज एक तीर दो निशान. On this YouTube channel only, tomorrow morning I am having that particular session, and in that session I'll be talking about कि how you can prepare for GATE and placement together with not double मेहनत. दो बार मेहनत करने की जरूरत नहीं है. With single study, how can you prepare for both? I will give you appropriate content, appropriate understanding, appropriate knowledge, and every single thing which will be required for your both preparation, GATE and placement. Strategy also I will provide, and I will provide the content also that how can you do that. Tomorrow morning you are having a session. Either it will be 9 a.m. or 9:45 a.m. tomorrow morning on the same YouTube channel. So we will be discussing एक तीर से आप दो निशाने कैसे लगा सकते हो. आपका प्लेसमेंट का प्रिपरेशन भी होगा एंड आपका प्रिपरेशन होगा किस चीज का? आपकी प्रिपरेशन होगी किस चीज की? आपकी प्रिपरेशन होगी प्लेसमेंट की भी और गेट की भी. Understanding this point? So tomorrow morning 9 a.m. or 9:45 a.m. I'll confirm in a minute. Okay, let me just check out it's when that particular session is. So tomorrow 20th, the time is 9:45 a.m. 9:45 a.m. 9:45 a.m. tomorrow. 9:45 a.m. tomorrow morning we are going to meet together. Okay, and in that particular session I will tell you appropriate manner through which you can prepare for placements also, and you can prepare for your GATE exam also, and not double mehnat, single time mehnat. That's it. Okay, fine. चलिए आगे बढ़ते हैं. Sir, are you taking another subject on YouTube? Rahul Raj, once this particular subject will be over, I will take another subjects. One by one I will take, just because other educators are also taking so many courses. You cannot learn every course running on the YouTube channel, right? So one by one I will take all the courses. 4 courses I will be taking this time on YouTube. All 4 courses. Okay, चलिए आगे बढ़ते हैं. Applications of linked list. But before we go for applications of linked list, all these complexities which I have written, please make down a note of all these complexities in a table wise manner. सारी कॉम्प्लेक्सिटीज को एक टेबल वाइज मैनर में लिख लेना अपने नोट्स में. एक बहुत अच्छी सी टिप है, बहुत इंपॉर्टेंट है. क्यों? क्योंकि डायरेक्टली समटाइम्स अ क्वेश्चन कैन बी आस्क्ड. A question can be asked directly that if this is the case, what is the complexity of this operation? Very simple. चलिए आगे बढ़ते हैं. Applications of linked list. What are the applications of linked list? What are the applications of linked list? Applications of linked list are you can store polynomials in the linked list. अब आप बोलोगे सर हमको उसकी क्या जरूरत है? What is the polynomial? First of all, let me see, and after that I will let you know what is the requirement of storing polynomial in the linked list. Okay, so let's talk about two types of polynomial we can have, and more also you can have univariate polynomial. Univariate means single variable. You have single variable polynomial. Let's say single variable, most of the time you will be having single variable x. So let's say that polynomial is looking like this: 6x cube minus 5x square minus 9x plus 2. This is one polynomial. Now how to store this polynomial in linked list? Each term will be stored on one node. Each term will be stored on one particular node. Each particular term will be stored on one particular node. How? Each node, each term has a coefficient and the power exponent. So the node will look like this. In the node you will be having a coefficient and exponent of x. Let's build the linked list for this particular polynomial. So we will be having a list pointer or start pointer pointing to the first node. First node has 6 as coefficient, power is 3. Next node, next term has coefficient minus 5. Yes, my dear friend, you will have to take this minus into consideration. Power of x is 2. Then you have next term coefficient minus 9, power of x is 1. Last term you have coefficient 2 and power of x is 0. 2 into x power 0, you can write it down. Like this way you can store the polynomial. अब आप बोलोगे सर इनकी जरूरत क्या है? You have seen such kind of polynomials and their operations in mathematics, right? Multiplying or adding some constant, multiplying some by some constant, multiplying by some polynomial and something, division of two polynomials, subtraction of two polynomials, and some kind of operations you have seen. If you have seen such kind of operations, what if you will have to write the code to perform those operations? जो आपने मैथमेटिक्स में सीखे हैं, अगर उन पे कोड लिखना हुआ तो सपोज आई एम सेइंग दैट divide this particular polynomial by x, what you will be getting? Or divide this particular polynomial by x square, what you will be getting? Or 2x square, what you will be getting? So if you will have to perform the operations, of course you can write the algorithm, of course you can write a program, and to write a program or algorithm you will have to store this polynomial somewhere. How? In the linked list you can store. Simple. Right? Let's say you are having a bivariate polynomial. If you are having a bivariate polynomial, then if you are having a bivariate polynomial, you will be having two variables. You will be having two variables. If you will be having two variables, you can have the linked list, or you can have the polynomial like this: 3x square y minus 6xy square plus 4xy plus 9. How do you store this particular polynomial? For this particular polynomial, you will be having node like this. In each term, you are having one coefficient, of course. After that, you are having an exponent for first variable x, second exponent of y, and after that, you are having a next pointer. So it's like more than one type of data you are storing on each node, and one pointer you are storing so that you can represent one entire term. This one, x and y will be given in some other variable. So first variable will be given to you, second variable y will be given to you. You can place the value while extracting the information. जो भी पहला variable है to the power this, second variable to the power this, and you can get the actual term. How do you create the linked list for this? How do you create the linked list for this? The linked list will be like this: coefficient is 3, power of x is 2, power of y is 1, and link pointer. Then second particular term will have coefficient minus 6, power of x is 1, power of y is 2, and next 4 is coefficient, power of x is 1, power of y is 1, and next coefficient 9, power of x 0, power of y 0, null. So whatever the polynomial is, you can store it like this way. To store polynomial, linked list is the best option for you in the data structure. चलिए आगे बढ़ते हैं. आगे है हमारे आपके लिए क्विज. चलिए तो जल्दी से ये पर्टिकुलर क्विज जो है वो आप सॉल्व कीजिए. सॉल्व कीजिए जल्दी से. व्हाट इज द आंसर फॉर दिस पर्टिकुलर क्विज नंबर 1? व्हाट इज द कॉम्प्लेक्सिटी टू डिलीट अ गिवन की वैल्यू नोड फ्रॉम अ सॉर्टेड लिंक लिस्ट? तो आपको एक वैल्यू गिवन है. You have been given a value. That value you will have to delete from a sorted linked list. Sorted linked list से वो value जिस node पे present है, wherever that value is present on whichever node, that node I'll have to delete. That is the operation which I'll have to do. Delete that particular node and tell me what should be the complexity for that operation. क्या होगी उस particular operation की complexity? चलिए आप लोगों के लिए एक और छोटी सी इंफॉर्मेशन है. जब तक आप ये क्वेश्चन सॉल्व करें मैं बता देता हूं आप लोगों को कि आप लोगों ने हो सकता है गेट 21 एग्जाम लिखा हो, नहीं लिखा है तो एटलीस्ट देखा तो होगा, राइट? गेट 21 का जो पेपर था थोड़ा अनएक्सपेक्टेड था, जस्ट बिकॉज एमएसक्यू बहुत सारे थे, अलग टाइप के क्वेश्चन आए हुए थे और उनकी वजह से जिन्होंने अच्छी प्रिपरेशन की थी उनकी प्रिपरेशन भी थोड़ी सी लो गई. उनका एक्चुअली एक्सपेक्टेड से थोड़ा नीचे आया रिजल्ट या आएगा रिजल्ट. तो आपको ये चीज सीखनी पड़ेगी. यू विल हैव टू लर्न दिस पर्टिकुलर थिंग दैट हाउ यू विल मेक द स्ट्रेटेजी चेंजेस, how you will make the changes in your strategy in such a way that you can cope up with gate 22 based on 21 का पेपर. 21 के पेपर के बेसिस पे आपको 22 के प्रिपरेशन की स्ट्रेटेजी को मोल्ड करना पड़ेगा, जस्ट बिकॉज दिस 21 पेपर वाज हाईली डिफरेंट देन एक्सपेक्टेड. सो मेनी एमएसक्यू क्वेश्चंस हैव बीन देयर. तो in that particular case, what I am asking is you will have to prepare for your gate 22 in such a way that you can learn from those things which have been asked from in gate 21. So क्या स्ट्रेटेजी चेंजेस आपको गेट 21 से सीखने को मिले, इसके लिए मैं एक सेशन ले रहा हूँ कल अनअकैडमी के स्पेशल क्लास पे. एब्सोल्युटली फ्री है. जी हाँ, आप आ जाओ उस पे 9 बजे सुबह और आपको 11 AM मॉर्निंग में, और आपको मिलेगा वो सेशन. एब्सोल्युटली फ्री है. यस, अनअकैडमी के स्पेशल क्लास पे. So you just come over there and you will learn how you will have to make strategy changes based on gate 21 for gate 22 preparation. ठीक है, चलिए. ओके, Pretha Sur, if you have this particular question, can you come tomorrow 11 AM on Unacademy's app? Download Unacademy Learner app and join my class tomorrow. That is special class, absolutely free. We will be talking about strategies about gate 22 preparation. Okay, what is the complexity to delete a given key value node from sorted list? इतने तो तुम लिस्ट बना के सॉल्व कर लेते हैं क्वेश्चन को. Let's say this is the list. 5, 8, 15 and 18, and I have told you that you will have to delete a node with key value 15. First of all, you will have to search where the key value 15 present. Whether the list is sorted, I don't care. I will have to find it linearly and that will take big O of n time. So I'll have to find out where the 15 is present. After that, I'll have to delete it. Complexity will be big O of n. First find, after that its predecessor का link is equal to its next node. whatever the session I'm going to conduct tomorrow on Unacademy's special class, that particular session is 11 a.m. tomorrow, and for that link is in the pinned up message. So you can check out the comment box. In that you have one particular message pinned up. That particular message is the link. Go to that particular link and click on notify me, so that you will get notified when the class will be there 11 a.m. tomorrow. Okay, is there any test series for GATE 22? Yes, there is a test series, but you cannot enroll only for test series. You can, or you should, you will have to enroll for entire plus subscription, and you will be able to access test series also over there. Chaliye, another question. Question number 2 for the day. Question number 2 for the day. Question number 2 for the day. जल्दी से बताओ. Question number 2. What is the complexity to remove a node from last and to insert it at the starting of the singly linked list? तो एक नोड को आपको सबसे लास्ट से डिलीट करना है, and you will have to add it in the starting. What will be the complexity? Option A, B, C, D. Which option is correct? A, B, C, D. Type down in the comment box. So look at this. Look at this. It's very simple. Two operations, one after another, you will have to do. What two operations? First operation is deletion from last, and after that you will have to insert that node, insertion at starting. These two operations, one after another, you will have to do. For single node, yes, single node. Deletion from the last will take big O of n time, actually theta of n time. And after that, insertion at starting will take constant time. Both will be added one after another. One after another, theta of n plus theta of 1, complexity will be n. Option C is correct. ऑप्शन सी इज करेक्ट. रोमित सोनी, रिजल्ट कब आएगा? रिजल्ट आई एम ऑल्सो एक्सपेक्टिंग कि आज रात